Hello and welcome to the first parts of guided notes for August 19th and or August 22nd. Today what we're looking at is evaluating all 6 trigonometric functions and using them to simplify expressions. This is probably part 1 of 2 or 3 videos, and you'll notice that it says all 6 trigonometric functions. So far what we've looked at up to this point are sine, cosine, and tangent. And if we're looking at the actual definitions of these 3 functions, I'm going to write SOHCAHTOA, however you want to say it. It's a device to help us remember these ratios. We're not going to pause. This is a ratio to help us remember, or a device to help us remember the ratios. We're going to start by looking at sine, cosine, and tangent. Now, if you've been following along and you're feeling good about what's going on so far, you might be thinking, well, we know that sine is y, cosine is x. That's true only if our coordinates or our degrees fall on the unit circle. Things change a little bit if they don't fall on the unit circle. And so we have to look at the actual ratios. So let's start with sine, cosine, and tangent. So we know that based off of this, sine is opposite over hypotenuse. I'm going to write that in terms of this angle theta. So we're going to use this triangle. So I'm going to say sine of the angle theta is equal to, so I'm looking at this triangle. This is theta, opposite over hypotenuse, opposite over hypotenuse. So sine is A over C. Which means if you do similar thing, cosine of theta is adjacent over hypotenuse, so B over C. And that means that tangent of theta, opposite over adjacent, would be A over B. So that's only if we're looking at this triangle labeled with these sides. We can define sine, cosine, and tangent based off this triangle this way. Now in class, what we talked about, there's 3 other ones. I'm going to actually write these in red, similar to what I did in class. There's 3 other ratios. The first one that I'm going to write is cosecant, or CSC, of theta. That's going to be C over A, or our hypotenuse over our opposite. Secant of theta is going to be C over B, or our hypotenuse over the adjacent. And cotangent of theta is equal to our adjacent over our hypotenuse. Now in class, what we talked about is there's a reason I wrote these next to each other. And in fact, if you look at sine and cosecant, these here are related. Sine and cosecant are related. If we can find sine, then cosecant is the reciprocal of sine. If we can find cosine, then secant is the reciprocal. Let me do this. Cosecant is the reciprocal of cosine. A similar thing with tangent and cotangent. Okay. So let's put this to use. I'm going to try to keep those on there. Maybe I can work this problem out with those there. So if we want to find secant of 7 pi over 4, then what we can do is say, well, we know that secant is related to cosine. If we can find cosine of 7 pi over 4, then we can take the reciprocal. So I'm going to start by saying cosine of 7 pi over 4. And we need to go to our unit circle, or hopefully you can have it memorized by now. You're going to need it memorized for your first assessment. And if we do that, we see cosine of 7 pi over 4 is square root of 2 over 2. Which means secant of 7 pi over 4. I'm going to take what cosine is, because cosine and secant are related. It's just the reciprocal. Secant is 2 over square root of 2. I take this fraction, I take the reciprocal, which is 2 over square root of 2. Now in past classes, what we talked about is that we don't like square roots in our denominator. We don't like radicals in our denominator. So to move that out of our denominator, we're going to rationalize it by multiplying by square root of 2 over square root of 2. And we get that that would be 2 times the square root of 2 would give me 2 square root of 2. Golly. And the square root of 2 times the square root of 2, square root of 2 times the square root of 2 would give us square root of 4, which is just 2. So that would go here. And then hopefully we can notice that we have a 2 in our numerator and a 2 in our denominator. We're multiplying, so we can divide the 2's out. And what we're left with is, really this would be square root of 2 over 1. But anything divided by 1 is itself. So we get that the secant of 7 pi over 4 is the square root of 2, period. On the next video, we'll calculate these 4. I'll walk through calculating these 4. And then in the third one, we'll just simplify some expressions using these functions.